Oh, hey, I didn't see you there. Wait, did you just say you want to learn about the unit circle? Alright, gamers, so to get started, let's draw a circle, alright? Alright, so there's your circle, okay. And then so let's break up the circle into the 4 quadrants, alright? Like that, alright? So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, now from here, let's draw lines here, 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 and here. Alright, and after a few just tiny little touch-ups, this is what our circle should look like. So as the name suggests, this is a unit circle, which means that the radius of this circle is 1. And the center of the circle lies on the origin for simplicity's sake, which means that this would be the y-axis and this would be the x-axis. Okay, so going with that logic, that makes this point 1, 0. And this point up here is 0, 1. This point over here is going to be -1, 0. And then this last point down here is going to be 0, -1. Now this line right here is in the middle of this quarter of the circle, which means, and since it is in the middle, that means that it's halfway from here and halfway to here. And since this forms a 90-degree angle, we can decipher that this right here is a 45-degree angle. And then these two angles right here are 1/3 and 2/3 respectively, which means that it is going to be 30 degrees and 60 degrees, since 1/3 of 90 is 30 and 2/3 of 90 is 60. Now doing this in terms of radians, we have 0, pi over 6, pi over 4, and pi over 3. And then lastly up here, we have pi over 2. And as we discussed earlier, this is going to be 90 degrees. Now you may be wondering why these are the numbers right here for the radians. And that is because in terms of radians, half a revolution around is going to be pi, or 180 degrees in terms of degrees. And then over here, it is going, one full revolution is going to be 2 pi, or 360 degrees. Now in the second quadrant, we have these angle measurements that are 1/3 away, 1/4 away, and 1/6 away from this value right here. And then since these are going to be reference angles to 60, 45, and 30, and you just subtract 180 from each of these to get 120, 135, and 150 degrees. Continuing on, these numbers are 1/6, 1/4, and 1/3 greater than this value up here for pi. And the same as we did with these, we add to get these numbers respectively. Now, since this right here is perfectly in between pi and 2 pi, the angle measure over here could be considered 3 pi over 2, also known as 270 degrees. Now, continuing with this trend, these numbers are 1/3, 1/4, and 1/6 away from 2 pi. And then we subtract 30, 45, and 60 from 360 degrees to get 300. Alright gamers, you sticking with me so far? Good. Alright, so on this circle, the sign of these angles is going to be the same as the y-valued point on the line. So for example, the sine of 30 degrees is going to be 1/2 which is the corresponding y value. Sine of 45 degrees is going to be the square root of 2 over 2. And the sine of 60 degrees is going to be the square root of 3 over 2. The cosine of these angles is going to be the same as the x-valued point on the line. Cosine of 30 is going to be the square root of 3 over 2, opposite to this. Since this is right in the middle, the cosine of 45 is going to be the square root of 2 over 2, being the same as the y value. And this one up here, the x value or the cosine will be 1/2. Talk about tangent of an angle measure. It is going to be the same thing as the sine of the angle measure divided by the cosine of the angle measure. So these x and y values, or sine and cosine and tangent numbers, don't change, but the signs do change when reflected over to the different axes. So in quadrant 1, all of them are going to be positive. Now in quadrant 2, the cosine and tangent are going to be negative, sine being positive. In the third quadrant, you have the sine and cosine are going to be negative, but since it is going to be a negative divided by a negative, the tangent is going to be positive. Quadrant 4, positive cosine, you have a negative sine value or tangent. All right, and once you consult this for reference and you just translate them over like this. Now, when we're talking about cosecant, secant, and cotangent, they correspond to the sine, cosine. You just take the reciprocal of the corresponding thing. So cosecant responds to sine, and you just take the reciprocal, which would be 2. Take the reciprocal of this, which would be 1/2. And you take the reciprocal of the tangent to get 4. All right, now let's put this into action so you gamers really know what's up. If we have negative 9 pi over 4, to find the 6 trig functions, we have to subtract 2 pi from 9 pi over 4. Then what you get is going to be pi over 4. What we need to do from here is jump up, kick back, whip around, and spin one full revolution around this way until we get back to here. And then we still have that extra pi over 4. So what we do is subtract pi over 4 from 2 pi, which leaves us right here at this value, which is going to be 7 pi over 4. Okay, gamers, since you worked so hard on crafting this unit circle, you already know what the sine and cosine are for 7 pi over 4. So the sine of negative 9 pi over 4, which is coterminal, which means that all you have to do is add or subtract some whole revolutions, and you'll go from this angle to the other. It's coterminal to 7 pi over 4, which, as I previously said, is already on here. You already know what the sine, cosine, and tangent are going to be. Now, for the cosecant, secant, and cotangent, what you do is you just take these values and just take the reciprocals. Okay, so you get the reciprocals, and then after you do some rationalizing, you get a cosecant of negative square root of 2, a secant of positive square root of 2, and your cotangent remains as negative 1. Alright gamers, then that concludes our little lesson on the unit circle. Now you could jump up, kick back, whip around, and spin just like your favorite ninja. Now isn't that right, Lloyd? Alright, so Lloyd's gonna sit here and just watch. Now as for me, I gotta get back to my Fortnite.